Welcome to section 5.7 for the online video lecture series for intermediate algebra at Wayland Baptist University. I'm Dr. Scott Franklin. I can't even pronounce my name. Leading these lectures. We are now to the final section of chapter 5, where we will be talking about polynomial equations and their applications. We have in this chapter covered how to identify polynomials, to add, subtract, and multiply polynomials, and in the last 3 sections we have been factoring polynomials. Now we're ready to answer the question, if we have a model equation that involves polynomials, how do we solve for the unknown variable? Our technique is going to turn out to use the factoring that we've been emphasizing in the last 3 sections. So let's talk a little bit about what we're going to cover in this section. We are going to cover 2 essential concepts in this section. We're going to solve polynomials or solve polynomial equations by factoring, and we're going to look at problems, word problems that involve polynomial equations using those techniques that we just talked about. So here we are. We're going to solve polynomial equations by factoring. Now before I even start filling in the notes here, I want to point out the problem we have with polynomial equations. Say for example we have something like x squared plus 2x say equals or plus 1 equals 0. The goal for this would be to try to get x equals something, right? But the problem in getting from here, this line, to the bottom line is how do we get x by itself? How to isolate x. And the reason why that is a problem is that we've got an x squared and we've got an x. And we know that we can't combine those together. So how can we get an x by itself when we can't ever combine the x squared and the x? Right? That's the challenge. So here's what we're going to do. By the way, let me introduce a term that we're going to probably express several times in this section. If I refer to something as a quadratic equation, we're going to use this definition. Quadratic equation in x is an equation that can be written as ax squared plus bx plus c equals 0, where a, b, and c are some real numbers in the problem, and a is something non-zero, so you actually have an x squared term in there. Okay, that's what we call a quadratic equation. And even if it's written where, say, the x and the b and the c are on the right-hand side, if you can get it into this form, it's still called a quadratic equation. So this example I wrote up here is a quadratic equation. A quadratic equation in x is also called a second degree polynomial in x, because quadratics are second degree polynomials. Remember, the degree of a polynomial is the degree of the highest degree within the polynomial. Sorry, yeah, it's that degree of the term that has the highest degree, which in this case is the 2. So it's a second or a 2-degree polynomial. Now, how are we going to solve that? Again, how do we get the x by itself? Well, we're going to use something called the zero product rule. The zero product rule is really our key that unlocks the door here. If the product of 2 algebraic expressions is 0, then at least one of them has to be 0. That is, if I have something like a and a b multiplied together, where a and b are like expressions, maybe not even variables in the problem, but expressions. If they multiply together to be 0, then you know one of 2 things is true. Either a has to be 0 or b has to be 0. That's the only way you can multiply 2 things together and get 0, is if one or the other is 0. Now, if the right-hand side was anything other than 0, that's not true. But for 0, if the product of 2 things is 0, one of them has to be 0 for that to be true. So what we're going to do is we're going to take this and factor it. So we have 2 factors multiplied together that equal 0. And if that's the case, then a solution would be something that makes one or the other, or both, of those factors equal to 0. So to solve a quadratic equation by factoring, if necessary, rewrite the equation in what I referred to earlier as standard form ax squared plus bx plus c equals 0. In other words, move all the terms to one side, thereby obtaining a 0 on the other side. That's the 0 that's the key for the zero product rule. At that point, factor completely. Then apply the zero product principle, meaning set each factor containing a variable equal to 0. Then the result will be you can solve those equations in step 3. They will actually no longer be anything but linear equations in most cases. Alright? Then you can, of course, as a last step on any solution problem where you're solving an equation, is check the solutions in the original equation. Now I will usually omit this step as part of the lecture for the sake of time, but it's certainly a good thing for you to do as you are working these problems on your own. Let us walk through those 5 steps with a few examples. Okay, so to begin with, I have x squared minus 4x is equal to 45. Note that it is not equal to 0, so the first thing I need to do is get this thing equal to 0. So I'm going to begin by subtracting 45 from both sides, leaving me with x squared minus 4x minus 45 equals 0. So to solve this, I first factor. Because there are 3 terms, I'm going to use the reverse FOIL factoring from section 5.4. That's factoring trinomials. I know the first 2 have to multiply together to give me x squared, so that's x and x. The middle signs will be opposite because that's a minus, so plus, minus. And then I got to look at 45 and say, how can I split 45 up? I can do 1 and 45, and I can do 9 and 5. So let's try 9 and 5 and see if that works. The outside gives me negative 5x, the inside gives me 9x, which adds together to be 4x, but I'm looking for a negative 4x, so I need to change these signs to minus and plus. And that's minus plus, so that works. Okay, so I'm going to erase this to get it out of the way, but that checks, that factors. Notice that I do have that 2 things multiply together to give me 0. So to solve this, to find the x that makes this true, you need to find an x that solves this, means make this 0. That would be a solution. Because if you find an x that makes this 0 and you plug it in, that x won't make this 0, but you've got 0 times something else. Of course, that is true. That does equal 0. So set this expression, or factor, equal to 0, and set this one equal to 0. Now those 2 are easy to solve. Add 9 to both sides. You get x equals 9 is a solution. That is, if I were to plug 9 into this, I get 9 minus 9, which is 0, times 14. 0 times 14 is 0. So yes, it solves it. Now this one I could also solve by subtracting 5 from both sides and get x is equal to negative 5. There is a second solution. This equation has more than one solution, which is certainly possible with polynomial equations. So 9 solves the original equation, and negative 5 solves the original equation. Now, of course, you can check, but I'm not going to take time out of the video lecture to do that. Just plug in one number at a time. Plug the 9 into the original equation and see if it satisfies it. And it should. Plug negative 5 into the original equation and it should satisfy it. And that works. Alright, what about the next example? We are asked to solve x squared is equal to 4x. Now again, we recognize that this is a polynomial equation because we have squares involved. It's quadratic or second degree. So our only approach to solving this at this point is to get it equal to 0, factor, and set each factor equal to 0. So let's first get this thing equal to 0. We're going to subtract 4x from both sides. You end up with x squared minus 4x equals 0. Now I need to factor this. Now I see 2 terms, so I might think factoring formula, but remember, before you do a factoring formula, check for GCF. There is a GCF here. It's x. I can pull an x out of both of those terms. And notice as a result, I end up with 2 linear or first degree polynomials, so I can set them each equal to 0 and solve it that way. That's all I got to do. So clearly x equals 0 is already solved, so that says 0 is a solution, which you can clearly plug in even in your head and check if that solves the original problem. To solve the second one, I would add 4 to both sides and have x is equal to 4. That also solves the original equation. Those are my two answers, and it will check out if you do it by plugging back into the original problem. This example has the binomial x minus 1 times the binomial x plus 4 all equals 14. Now you might be tempted to try to set these both equal to 0 or maybe both equal to 14, but that doesn't work. This has to be equal to 0. So my only choice here is to multiply out the left-hand side, move the 14 over, and get the resulting quadratic equation. So let's multiply out to the left-hand side. Let's simplify that. So using FOIL, I end up with x squared. The outside is 4x. The inside is negative 1x, so that gives me a plus 3x. And then minus 1 times 4 is minus 4 equals 14. To get it equal to 0, I will subtract 14 from both sides, leaving me with x squared plus 3x minus 18 equals 0, which I can now factor. This is an x and an x. They're going to be opposite signs, plus and minus. I look at 18 and see, well, that splits into 2 and 9, 6 and 3, and of course 1 and 18. I think 6 and 3, if I plug that in, turns out to work because the outside is minus 3x. The inside is 6x. 6x minus 3x is 3x. So now I set each of these equal to 0. Subtracting 6 from both sides, I end up with x is equal to negative 6 as one solution, and add 3 to both sides, I end up with x is equal to 3. Alright, again, you can check by plugging, say, negative 6 into the original equation and see if it's true. In fact, I can do that, I think, pretty quickly in our head, right? Minus 6 minus 1 is a minus 7. Minus 6 plus 4 is a minus 2. Minus 7 times minus 2 is 14, so it works. Similarly, if I plugged in 3, 3 minus 1 is 2. 3 plus 4 is 7. 2 times 7 is 14, so it also checks. Now, if you need to write that out, by all means, do that. It's just a good way to make sure that you've got the right answer once you get to the end. Now, take a look at this problem. We have x cubed minus 2x squared minus x plus 2 equals 0. This is no longer quadratic, right? This is higher degree than a quadratic equation. But the same technique applies to all polynomial equations. In other words, get it equal to 0, factor it, set each factor equal to 0, and solve. So we got it equal to 0. We need to factor. How do we factor 4 terms? Remember, if it's 4 or more, we're going to try grouping. So we're going to put these together. In the first two, I can pull out an x squared, and I'm left with x minus 2. In the second two, there's nothing in common, but the first one's negative, so I'm going to pull out the minus 1 and be left with x minus 2. Notice the x minus 2 in both terms, so we pull that out. We're left with x squared minus 1 equals 0. And looking at this, I can see I can factor that further. That's a difference of squares, so I end up with x minus 2 times, since that's an x squared and a 1 squared, to be x plus 1, x minus 1 equals 0. Notice how now they're all completely factored. because they're all first degree terms. So just like we set the two factors of a quadratic equation to equal to 0, we're going to set the three factors of this cubic equation equal to 0. So I have x minus 2 equals 0, I have x plus 1 equals 0, and I have x minus 1 equals 0. From the first equation, by adding 2 to both sides, I get x is equal to 2 is a solution. By subtracting 1 from both sides, I get x is equal to negative 1. And by adding 1 to both sides here, I get x is equal to positive 1. This cubic equation has three solutions. Now, just a side note here, I'm not even going to write this down because it's not something you're going to be required to use on a test, but you might see a connection between the number of answers or solutions and the degree of the original polynomial, right? Most of the quadratic equations that we covered, the second degree equations, had two solutions. This is a third degree equation, and it has three solutions. Now, that's not always guaranteed. It's not always going to be that a cubic or a power 3 polynomial has three solutions, but what you can say is that's the most number of solutions that it can have. A quadratic equation will have at most two. This cubic equation could have no more than three solutions. But this is how we would find it. We just get it equal to 0, factor, and set each factor equal to 0 and solve. In this word problem, we're given a particular model equation that that models a scenario. In this case, it's a gymnast. A gymnast dismounts from uneven parallel bars at a height of 8 feet with an initial upward velocity of 8 feet per second. Now, from a simple physics class, which you don't necessarily have to have had before you've taken this, you could derive that formula for this particular scenario based on Newtonian physics, but we're just going to be given the formula. In this case, the function is s of t, which is height, is equal to negative 16t squared, where t is going to be the time in seconds, plus 8t plus 8. That's the height of the gymnast's feet above the ground, right, in feet, t seconds after mounting. So you could figure that out. And that's the graph of the function given below, just plugged into, say, a graphing calculator or into something like Excel. But the question I want to ask, and you can see it here, but I want to confirm this using the equation, is how long after the dismount before the gymnast lands. Right? How long before they land on the ground? It appears to be 1 second, but is it a little before, a little after? Can we trust the picture here? Let's do it using the model equation. Now, what is the height of the gymnast once they land on the ground? Right? That's clearly 0. So we're going to let or use s of t equals 0 to solve this. So we're going to have negative 16t squared plus 8t plus 8, which is their height, that's s of t, and set that equal to 0. Notice this is now a quadratic equation, one that we need to solve by factoring. Now, how do you factor the left-hand side? You start by pulling out the greatest common factor, which, because the first term is negative, you pull out the negative as well. I can pull out an 8 from each of those. And pulling out a negative 8 leaves me with positive 2t squared minus t minus 1 equals 0. Notice how pulling out the negative just changes the sign of that term. And you can check. If I were to multiply this out, I do indeed get the original equation. Now we factor. So two things have to multiply together to give me 2t squared. So 2t and 2t. This sign tells me they're positive and negative. And the only thing that can work together to give me 1 is 1 and 1. Now let's check and make sure that works. Minus 2t plus t is a minus t, so that is correctly factored. Now you're going to take every factor that has a t in it and set it equal to 0. 2t plus 1 equals 0, and t minus 1 equals 0. In the first one, subtract 1 from both sides. You'll have 2t is equal to negative 1. Dividing off the 2, t is negative 1/2. Now, if t means the number of seconds after dismounting, this does not make any sense, right? T being negative doesn't make any sense in the context of this model. So I'm going to rule that answer out. Even though it is a solution to the mathematical equation, it is not a solution to the model problem, the original problem. If I add 1 to both sides on this equation, I get t is equal to 1, and in fact that's exactly what I expected. So it's after 1 second that the gymnast lands. So it takes 1 second. And that's our final answer. Alright, I want to close off with one last application problem that involves quadratic equations. And one place where you can see those quadratic equations show up is if you know something about the dimensions of right triangles, because the right triangle formula, known as the Pythagorean theorem, involves these squares. Hopefully you'll remember. If not, don't worry. I've got you covered. I'm going to teach it to you right now. If you have a right triangle, meaning that one of the angles is a 90-degree angle, so this right here is right, and if you were to label this side as A and this side as B, the shorter sides are called the shorter edges of this triangle are called the sides, and the longest side of a right triangle is called the hypotenuse. Then the relationship between A, B, and C is always A squared plus B squared is equal to C squared. That's true for every right triangle. Alright, so say for example we're given a problem where we've got this tree. I'll demonstrate my wonderful drawing abilities with my little pen here. Doesn't that look like a tree? Of course it does. Or broccoli, but we're going to go that it's a tree. A tree is supported by a wire, okay, that's connected a certain height up and then attached to the ground. Okay, this distance right here is 5 feet. Okay, we're going to assume that's a right angle right there. And here's what we're told: the wire is 1 foot longer than the height it reaches on the tree. So if I let x equal the height on the tree, not the height of the tree, but how high up it goes, right, called this side here x, then the wire is x plus 1, because the wire is 1 foot longer than the height that it reaches on the tree. Now I see my right triangle here, just like I saw it up here, so I'm going to take and show that the relationship between these sides is the Pythagorean theorem. I'm going to show that. I'm going to use that. Okay, I'm going to take 5 squared plus x squared is equal to x plus 1 quantity squared. Now I begin solving this by simplifying each side completely. I get 25 plus x squared equals, and using the fact that x plus 1 squared is x plus 1 times x plus 1, I FOIL out the right hand side. I get x squared plus 2x plus 1. Now as I try to get this equal to 0, first thing I notice is that if I subtract x squared from both sides, they completely drop out. I'm left with 25 is equal to 2x plus 1. Now that I have 25 is equal to 2x plus 1, I'll subtract 1 from both sides. Notice, by the way, by these things subtracting out, I no longer have to deal with a quadratic equation. It's linear. I can solve it. Okay, the point is, the original was quadratic, but as you start to solve it, sometimes nice things happen. In this case, it did. Subtracting 1 from both sides, I end up with 24 is equal to 2x. Divide both sides by 2, I get x is equal to 12. Now, is that my final answer? Well, the question was to find the length of the wire. Well, what is x? X was the height on the tree. So how do you find the length of the wire? Well, you remember, or you use the information in the problem, length of wire is 1 foot longer than the height on the tree, so it's 13 feet is the final answer. Okay, so another example where you might see a polynomial equation show up, and those are some techniques to use to solve it. Alright, that is the end of section 5.7, the end of chapter 5. And for those of you that will be taking a college algebra class following this intermediate algebra class, you'll be using a lot of polynomials as soon as you get into college algebra. But that ends intermediate algebra in your online class for Wayland Baptist University. Thank you very much.